Hello, everyone. My name is Murat. I am a co-founder of Magnimind Academy. So I'm a Stanford scientist and data scientist. I work in a lot of healthcare data and implement data science models in there. Before I introduce our speaker, I will talk about what is Magnimind Academy is doing. So basically, my Magnimind Academy is organizing all these meetups. We started as a meetup group in Bay Area, and now we are launching broadcasting all around the US. And we have actually several attendees from New York, Chicago, and other places in the US. So last year itself, we organized 70 events, including lectures, workshops, boot camps, and we hosted over 6,000 people. Hopefully, with this year, our new broadcasting, we're reaching out more people, and hope that people will benefit from our programs. So due to that coronavirus causing limitation in our lives, we decided to move all our programs online and hope that we bring ease to our members' lives and hope that they can benefit from our programs. So what we have several meetups. We announced some of them. We're gonna announce more. There's several exciting topics we'll cover in the next couple months. And we are also launching several mini bootcamps. They will be free. Most of them will be free. And one of them, next one, we announced that it will be next week. There's a free mini bootcamp Python based on Python and data analytics, and it's given by one of our instructors from Stanford. And following to that, we'll have machine learning and deep learning bootcamps, which we will announce shortly in a couple days. We actually started another program, and we had a deadline much later, but we took the deadline earlier, and we will start next week. The people stay home. They demanded that program to be online. They demanded that it should start soon. We are starting a one-on-one mentorship-based project bootcamp. So that one-on-one mentorship-based project bootcamp, the self-title tells a lot. So deadline will be on Wednesday. So we get a lot of applications. So we'll select the qualified people from this qualified people from those applications, and we will tailor the program for people's needs. And we offer them extensive 7 weeks program. That program will include several project-based teaching, and every student will be assigned to 3 to 5 mentors, depends on what they need. And during that 7 weeks, we will have practice interviews. We have career coaching. We will have a resume support, and the mentors will be from companies in Silicon Valley where the Magnimind is located now. And at the end of the 7 weeks, the students will have a chance to do internship with the companies that we are collaborating in our projects. So after 7 weeks, if they're a good mutual match, and the students will be able to continue as an intern in some of these companies. So if you have interest, there's 2 days left in the mentorship program deadline. I hope you guys can join. And today we have an exciting program and an exciting speaker. And today's topic is really cool. So what will be in AI industry in next 10 years? And it's given by Mohamed El-Geish, and he has an amazing background. He had a startup, and startup called Voika. He was a co-founder and chief architect, and he was acquired by Cisco, and now currently he's a director of AI at Cisco Contact Center Solutions. And prior to that, he worked in LinkedIn and Microsoft. He led the AI and big data teams that serve hundreds of million users. He also co-authored a book called Competing with Data that explores the big data industry. Mohammed has also been teaching deep learning as a teaching assistant at Stanford. I think is a fantastic speaker to benefit from. I hope you guys liked today's program. You enjoyed. Please give us your feedback on our programs. Thank you.
All right, thank you so much, Murat, for the introduction. I'm very excited to be here, and I would like to, start by telling everybody like this is unprecedented time. So feel free. This is an informal for me, like informal, setting. Don't worry about anything. Feel free to interrupt me. Feel free to like ask questions. I will find a good, point in time to like answer them during the talk. And at the end, we'll have like an open discussion. I like the interactive discussion for this kind of talk. So as you mentioned, like I want to like give you an idea of what I think personally the AI industry is going to be like in the coming 10 years. Of course, like, nobody can predict the future. That's very clear now. Nobody could have predicted what we're, living in right now, the situation we're in. But I want to give you some really backward looking, overview of like how things have been. And then from that, we can both together extrapolate how things would be. So the goal for me today, if anything, is for you to go and think on your own how the next 10 years will be like. So let me share my screen here, and then we can go to presentation mode. All right, so as Murat said, I'm a director of AI at Cisco, co-author of Computing with Data. It's a book that tries to bridge the gap between the skill set required for working with big data, if you're coming from a background in statistics, physics, chemistry, whatever have you, versus coming from computer science. And you can see the two camps being separate today. We want to bridge that gap and equip you with the skill set that allows you to work on big data systems, and like really going through a list of projects and companies and practices that my co-author and I gleaned through the years. Before that, I was chief architect and co-founder at Vuisia. We worked on AI for meetings. So you can have a meeting assistant that takes notes for you automatically. And before that, worked at Microsoft and LinkedIn on various projects, including AI and big data. All right, so as I said before, it's really hard to make predictions, especially about the future. The goal of today is to make sure that after this, you think of what skill sets you should be equipped with in the future, in the next 10 years. If you're gonna invest in, in a job or invest in a company or start one, you need to know how the future is gonna look like, or kind of guess, but it's an educated guess. And there's one thing for sure that I know, in the next 10 years, I don't think there will be AGI, right? Artificial general intelligence, and no AGI mentioned in this talk. So if you are here for this, I'm sorry, but I think it's a little bit ahead of its time. We will see more improvements in other areas before we talk about AGI. All right, so to predict the future, I think it's important to revisit the past. We can learn a lot from the past and see the trajectory of things, how they're going. And we've come a really long way in the three pillars of any AI solution that allows us to have AI at scale that's very useful. If you think of the pillars, they're the compute power, the research, and the data. So I'm gonna walk through these three and give you an idea of like how far we've come. In the compute arena, we already know this. Everybody has seen this chart before in one shape or form, and you can see the kind of insane growth, right? In terms of like how many flops we can do now, and like the size of like the chips that we have. The iPhone that you have right now has way more capability and computing power than the guidance shuttle, the guidance computer in like a space shuttle that took us to the moon. So just looking at this image, and folks have been lucky to work with this, GPU, like if you have a couple of these, you can do a lot of experiments with AI, you can do a lot of, very powerful computations that have been really challenging in the past. It used to take them months, maybe like weeks, to do the things we do today in hours, or sometimes less time, thanks to the compute power we have. And of course, the same thing applies to the algorithms or the research, right? So without the people, without the talent, without the research that happens, if you think of like back in the day, how computation used to be done, and now like all of these enhancements, all of these advancements we have, they just allowed us to do things at scale we've never dreamt of before. So I'm not gonna go through every single one of them, but just like very quick overview. These are the things that started like, in the past 70 years or so, Turing, test, and like after that, the multi-layer perceptron and the perceptron, all of these different things that allowed us to think about neural networks and machine learning, AI. One of the big advances, like, making sure that things scale very fast is like not here on the list, but the ReLO function, for example, allowing us to do things at much higher speeds, much faster than ever before. And I'll be remiss if I don't mention the very last advancements in, for example, NLP, right? So we get all of these like pre-trained contextual embedding models. So all of the Muppetware that you hear of, the transformers, this has changed the landscape of the whole field, which is NLP, for example. Like before that, of course, Word2Vec and others. But the idea now, it's really democratizing how you can start with NLP. There's less emphasis on stuff that we had to worry about before, like linguistics, still important, but of course not as important, as vital, as before. Same thing if you think of like maybe speech recognition, 2016 timeframe, people used to have a lot of like domain knowledge to be able to get into an ASR, an automatic speech recognition system. Now it's much, much easier. Thinking just of neural networks as a democratization and requiring less and less of the domain-specific knowledge, and thinking of them as a universal approximators of like what you're trying to do in terms of mapping between input and output, has been a fascinating achievement for all of us that been witnessing this in the research community. So this is just setting the stage for how research is going to improve in the next 10 years. You've seen the trajectory and how fast things have been moving lately. And now this is one of my favorites. I think everybody here has a personal story. I'm going to share mine with you, and feel free to figure out like how this translates into yours. So in the 1980s, from what I remember, the share of computers, or like the amount of data has been generated by a person, has been almost close to a zero, right? So digitization of digital records, or records generally speaking, and how we can keep the data, but also like how much compute power or how much access to data that you have, or how much data do you generate. Really, the emphasis here I want to highlight is like how much data is a person you're generating. In my personal case, in the 80s, I think I was fairly zero. Maybe the government had 1 or 2 records on me and some database, but that's mainly it. And some people had access to like timeshare on a computer somewhere, maybe in a university, but I think it's fair to say it's almost zero. In the 90s, we started seeing desktops, right? Whether it's at your school, whether it's at your house, but there are plenty of desktops around. So maybe your share now of the compute or the amount of data produced is like, 0.2 per person. Like if you have a family, if a household of 5, they're sharing one desktop, and they maybe have some like, I don't know, Excel sheets or Word documents or some data. It's still highly fragmented, not super useful for like, analysis of like multiple terabytes of like data that's required to do something super useful across multiple computers, but it's not super connected yet. Yes, there's the internet, maybe there's email services in the late 90s, but the amount of data required, amount of clean labeled data required to do something serious with machine learning isn't there yet. And then enter the 2000s, and suddenly we have cameras, we have phones, we have iPods and laptops and gaming consoles that are producing a ton of data. Even your landline is now most probably a VoIP connection. So you get all of, smart TV that understands your habits. All of these things are generating more and more data in the 2000s than ever before. And we have good understanding and good systems that actually can start doing way more interesting things with the amount of data produced. Now, a mere 10 years later, you get an explosion. Like I just took that circle and put it up there to show you like how much of the total sum of the pie represents. And you can see the examples I have here. It usually works best in an interactive mode. I want to give you a minute or so just to pause and think of your surroundings, the connected devices that you have, the IoT, all of the things that we have been interacting with in the background. They're just sitting there collecting data, whether passively or actively when you're interacting with them. How many of these you have noticed that they're actually sending data streams to the cloud or doing some processing at the edge, and they're useful IoT data generators? How many of these you have around you right now as we speak? In fact, I'm talking to you right now and I'm wearing these like glasses. They're not just a fashion statement. I don't like the design per se, but they have a microphone and speakers, and I can generate data from an accelerometer. They have multiple sensors. They know how much like time I spend on calls. They also know in which direction my head is oriented. So there's a lot of information, a lot of data that's being generated from these devices. So I want to pause here for a second and maybe ask you, anything on the screen that catches your eyes, like there's no way this is connected to the internet or generating data? Okay, I'll pick my favorite example, which is this paw right here. As a matter of fact, my dog is sitting right now at my feet, and she's wearing this sensor that's really like a Fitbit. It's called Whistle, and it's generating not just exercise and like activity data, it's also a GPS and it's connected to the internet, so over 2G. When you have your dog connected to the internet, and you can always see what's happening, like where your dog is and how much activity your dog has been getting, it's really a different world, right? So this is something that we could not have predicted maybe in the 2000s, let alone in the 1980s. So just think of the things that will be more connected in the future, or deeper connected, and sending way more data than they are today, and the novel applications that will be connected, or the novel devices that will be created and connected. So I don't have a fridge here, but a lot of fridges are connected to the internet now. Shoes are even connected to the internet. So a lot of devices are happening, coming about and producing a ton more of data, time series data specifically, that could be much more interesting to produce models for and getting some interesting insights from. So there's a lot of data coming out from your household, from everything you're doing, and a lot of connections to be made. And that's really the more interesting thing, in my opinion, than what we call the first order, is the second order connections that you can make. So yeah, it's interesting to see that your dog is maybe more active today than in a week from before, or this month than last month. But if you think of this one here, it's actually the interesting insights you can connect or glean from connecting the dots. So this bar chart, for example, is from my faucet, which is also connected to the internet. Today, I can talk to my faucet and say, like, just pour me a cup of water. Or actually, recently they said, like, wash my hands, and it will give you water for 20 seconds to make sure that you're washing your hands properly. But then the thing that's really interesting, it's connected to Alexa. So technically, when I'm giving a command, Alexa knows when I'm using the water faucet, but at the same time, it's one OAuth scope away from knowing my usage, right? So technically, Amazon could have access if this API is connected via the Alexa application or skill. It could have access to my water usage, right? And you can see here, there's a spike in water usage in April. And it's not because I adopted a new dog. It's actually because my parents were visiting. But now they can glean from multiple sources, maybe through Alexa, different voices in the house, and now more usage of certain utilities, that there are more occupants in that household. Maybe we should give them some coupons or some discounts for, like, guest towels or some other like interesting things that they can use in the retail space. So really the second order data sets, or the second order connections that they can glean from smaller data sets are way more interesting. And there's a lot of data mining to be done there. So let me pause here, because this is a good transition I don't see any questions that are new, but if you have any questions, there will be a good time to stop and ask. All right, maybe at another break. So let's make the predictions. The first one has to do with regulations. I think just thinking about like what are the connections I don't want to be made, right? I like my data to be siloed. I like to have my, for example, music not connected to the Apple ecosystem. I want to get it from another source so that I can move around as much as I need to, or I can switch between platforms. Same thing I'd like to have in my data. I want it to be anonymous to an extent that I cannot be tracked, because I don't think of myself as a generator of data for profit that I don't get back, right? So unless the service or the product is actually giving me back something in return, I don't want to volunteer my data set for free. So I think that GDPR and CCPA and all of these like laws we've seen are a good thing in general. They're protecting us, right? They're protecting all of the people who do not really see the impact their data can have on society in general, and like decision making and other things we've been witnessing in the last couple of years. So the idea of having laws and regulations is in general a good thing. The application of it, the understanding of it, that's really the subtleties and the nuance of it is really the interesting pieces where we have to educate the legislatures and people who are in decision of making these laws, enforcing these laws, and like really coming up with these laws. The idea is that could be just a start, and we actually need a good understanding at the business level of what's to come and how to be ready for it. So when you're starting a business, when you're building a new team that's working with data, you have to think of these things ahead of time, not as an after the fact kind of like, oh, let's now go and figure out like what we need to do with the data collection or with these like, laws we've ever heard of. That reminds me of an episode in Silicon Valley, if some of you are familiar, when they discovered like, oh yeah, we did not make, the proper like user agreement for this law, or somebody who's like a minor or like younger than 13 years old can sign up. You have to make sure that you have a good understanding of all the laws in your space and understanding how to be compliant, and of course preparing for the proper data privacy regulations and self-enforced ones as well, not just regulations. Just because you have to comply with GDPR doesn't mean that you restrict the GDPR protection to EU citizens. What about the rest of the world? So I think it's setting a good example of what to be followed. And in our businesses, we have to be fully aware of like where is the puck going, and we have to be ready for it. So I imagine or predict rather that there should be some agency that is aware of like the practicalities and the really the spirit of the law than the letter of the law. There's some GDPR clauses and certain things in the development of the GDPR that were just unreasonable. And I think an FDA-like agency, maybe like a federal data agency, would be that agency that protects us consumers from misuse of data at scale. And I think that two top domains for this are going to be the health domain and the legal domain. So you will see actually a lot more of AI almost in every industry, but these two are specifically super sensitive to certain aspects of AI and machine learning, like explaining how the model made a decision. Because when we're talking about these of AI in a legal domain and the courthouse, for example, and making decisions about like sitting bail, right? And who's more prone to like escape if you don't set the proper rules and laws and enforce them, and who can get a certain sentence because of like their past history, criminal history. And I don't want to go into like Minority Report, but these things have real applications today, and some courthouses in the US have been actually using AI in certain applications, and it's super important to explain why did the AI made this decision in these domains specifically. And then I think we want to avoid another Cambridge Analytica, although I think another one is going to be expected. We're not there yet when it comes to like privacy rules and regulations. there are a lot of, I would say, gray areas, and they might be stricter to really stop us from seeing another Cambridge Analytica. The idea of using data to actually influence the behavior of a big group has not crystallized or been captured in the law yet. It's harder than the other rules, which is like anonymization of data or how you encrypt the data. But understanding the impact of big data at really universal scale, like having data on billions and billions of people and like using that in a very targeted way hasn't been fully understood yet. So the next prediction is about research. And I believe that self-supervised learning is going to be making like really large strides and huge wins in the next 10 years. The idea of like what you saw before in IoT and connected devices coming out with a lot of time series data sets that are just too vast and too fast paced to actually be labeled. So the idea, as you know, like there's supervised learning, and supervised learning, you have some maybe a human coming up with like the ground truth data or labels, right? And this requires a lot of, it's labor intensive, requires a lot of care, and it just costs a lot of money and time and effort. But self-supervised learning, you can start with a software or like another machine learning algorithm, or a small seed of ground truth data, and from that you can do self-training or self-supervision or semi-supervision. And there's a lot of like different techniques to produce much better results at a high efficiency economically, right? So you don't have to label everything, but you still get really good results. So with this like abundance of data, we need some more eloquent algorithms that will understand the data without the need of a human in the loop, or with minimal involvement from humans in the loop. Now, we already saw this in machine learning in NLP. We saw this in, for example, like, BERT, when you have like huge corpora, and then you take 15% of the words and you mask them out, and you ask the model to predict what was the word in that context. This is a great example of like what's possible for other subfields as well. And I think it's because the research area we're talking about, self-supervision, is a hot research area that usually translates into backing, translates to a lot of like different improvements in the results and so on. And I need to like quote Jan LeCun. He's been really pushing this for a while now, especially the last couple of years, and he emphasizes that doing this properly is really going to be the greatest thing in AI for the next few years. Okay, so this one is one of my favorites. Even before Benj, you talked about it, and having like reference that book that everybody should really read. It's the book is called Thinking Fast and Slow, and it talks about like how we have two different systems, in our brain, or the way we think. And it's basically system one is more like your lizard brain, just reacts. It's very fast. It's what you use when you're playing tennis and just like, hit the ball with the racket. You don't really stop and think like which angle and how much power I'm gonna put behind this, how much force I'm gonna put behind this. It just happens. It's like natural. This is really the system that handles tasks that take a split second reaction and doesn't require much pondering or thinking deeply. And then you have system two, which talks about thinking about the more involved and more strategic decisions when you sit down and think slowly. And so far, we have been doing more of the former and less of the latter in terms of the AI. If you translate that to AI tasks, like, oh, look at this image and tell me, is this a dog or a cat? It's a split-second decision, right, for humans, and the same thing for, of course, much faster for computers. But then what if I tell you, like, why? And you start thinking about, like, what really is in a dog? What is it that makes a dog? And like you start thinking about, like, how to abstract that level of reasoning and apply it on a more, more than just a dog, like other animals as well, or other tasks to start with. So what we're trying to do here, and you know, when I mean we, I think I was referring to like Benjio and his team, and that was actually before their presentation at the session in Europe's 2019. There was also a couple of talks, but the idea is like this is a hot area as well of research. I think it's going to see a lot of like, you know, improvement in results very soon. The idea here and the goal is to make sure we can generalize better and use these tasks to build modules. And these modules could be used for reasoning about the world. And then you can use that in different domains and different settings. So if you can understand, the models can understand high-level concepts and abstractions, it's just like a child. They only need to see 1 or 2 examples of dogs, and then they can easily understand the concept of the dog, versus a machine learning algorithm today has to see a dog in so many different settings from so many different angles, and that's how it learns that this is a dog. So the nice thing about that, models will learn from way less data, right? And this is kind of the notion they're using to find the right model for that, which is if a model can learn using much less data, then maybe that's the right abstraction that will allow us to figure out the reasoning or system to understanding of that thing it's trying to learn. And then the method learning here is that you can take this module that just like trained to understand the concept or the abstraction of a dog, and now you can use it to do other things and novel tasks. Maybe understand the shapes of like a stop sign, maybe understand the shapes of a crocodile. So it doesn't matter what the animal is, but you can understand what it means to be like an animal or a stop sign and so on. Okay, I think we can pause here again for questions. That's a good break point in the presentation before I talk about AutoML, because that's more of a business discussion to an extent. All right, we can move on. So what is AutoML? If you think of how today we've been doing machine learning and how we're labeling data, right? For a lot of the tasks we're assigning the machine to learn from or not learn for, the models for, you have to do a lot of work, right? You have to come up with the proper data representation, the model architecture, hyperparameter search, evaluation, and so on. But what if the machine can take that role as well, right? So just think of like how we, to an extent, automated representation or did representation learning, right? So back in the day, you might have to do a lot of like feature engineering, and the feature engineering requires domain knowledge, right? So you have a lot of these very like interesting tricks, I would say, maybe, that the human mind has a limitation that come up with like so many of them, but now the neural network can come up with a very complex representation for you without you coming up with it in a linear or like, you know, kernel trick fashion. So extend that thinking or line of thinking to the entire pipeline. If you can think of like how you can start from a data set and just do not do hyperparameter tuning, the machine does it for you. You do not do architecture design, the machine does it for you. And the good thing about it is that we have been doing this for the machine for a while. We have been doing a lot of this labeling, right? We know now, like, okay, this is a good architecture for this kind of problem. Go and learn from that. And maybe in the future, you can do it end to end. So it's a true end-to-end learning. You don't have to like think of it as multi-stage process. You start with the data and the machine comes up with the proper model for that task, and it just learns the rest of the pipeline for you. So the nice thing about it is that we will see this in so many different domains that might not have the sufficient number of experts, right? If you think of that today, AI is not really dominant in a lot of the non-tech domains, for example, like agriculture or manufacturing, and you can see so many opportunities, like let's say gas and oil, right? Industry. The AI is not there yet, in my opinion. It's not just scratching the surface. It's not at, you know, at a degree where we can say like, yeah, it's really been utilized well. And the number of experts who can actually come with models and ideas for the machine learning models from that domain is going to be very small, in my opinion, for the needs that are going to come in the future. And that's a good thing for AutoML to come in and kind of help these domains, introducing new techniques and introducing novel ways of coming up with models that maybe we have not thought of as humans. So it opens up the door for a lot of non-experts. Maybe you're a savvy business user and you can just build a machine learning model, and it's the real democratization of machine learning. Just like I mentioned earlier, neural networks democratized a lot of the domain-specific knowledge required, and almost anybody who has some strong, experience with like neural networks can take their learning from like translation, like neural translation models, and apply that on speech recognition or computer vision. There are a lot of like cross-pollination that's happening today, and you can see that because the neural network has taken that feature engineering and the domain-specific knowledge, made it secondary. And this could be the same thing here, AutoML making the architecture search or hyperparameter tuning and all the other things we've been doing as machine learning practitioners to be secondary as well. Okay, so I saw a couple of questions in chat. I've been looking only at the Q&A tool. I apologize. Let me see if I can answer this one. So, it's from YouTube. Okay, so the first one is, what's GDPR and CCPA? These are two laws for the European Union. It's a general data protection regulation, and the other one is for California. Very similar idea. The idea is to protect your data, whether it's by making sure it's encrypted the proper way, at rest and in motion, or there are proper procedures for communicating, like exposures or breaches of data. There are a lot of articles. I'm not going to go through them one by one, but the goal and the idea is to make sure that a business or a company that handles your data is doing the proper best practices to protect your data. So at any point of time, when you think of the past before GDPR and after GDPR, I think it's a move to the right, in the right direction, and it's for the most part very reasonable. I think there's some stuff during the formulation or coming up with the GDPR that will not make sense if you want to really go back to the discussions and the the making of it and hear the stories. There's some interesting stories there, but overall, it's just a protection set of regulations to make sure that your data is protected when it's being used, and you own the data. It's another thing that's really important, and the company that's handling your data is just a processor for your data. All right, so how do you think about the interaction of AutoML and model explainability? That's a great question. Explaining models is hard as is, right? If you're using a neural network, there's a lot of techniques you can do today to make sure that you understand some of the, maybe like, at a neural network level, what is each layer doing, especially if it's like computer vision, it might be much easier than other tasks. But then the AutoML thing could come in and just change all this, so you can find these, like, for the lack of a better term now, bizarre configuration or bizarre architecture, right? And you would think about it as like, that does not make any sense. Why is it doing this very complex and very weird, like, configuration? And this might, make it much harder for you to understand what's going on. That said, I think of like model executability that tools or frameworks that uses the model as a black box as a good, alternative here. So it doesn't matter what's inside. You might not even know how it's being built, but you can do a lot of testing to see, like, okay, now I understand, like, it's actually looking at this region of the picture to determine this is a dog or a book or a cat or like phone. So it's not necessarily much harder, but at the same time, if you were able to like peek under the hood, you might not like how the AutoML. Of course, you can add constraints and whatnot, but let's assume that it has free reign and comes up with like a weird architecture or weird setup, you might not like what happens, because as a human, you did not think of this, connection or graph or like some weird decision it made, but it might make sense in the absolute. So, all right, we have new questions in the Q&A tab. You're absolutely right. What are great ways to be anonymous online? That's a great question. I'm not really the best to talk about that. There are a lot of, more suited security experts that can tell you. I think from my personal practices, yes, VPN is good whenever you can. Using some of the, I would say like privacy-friendly tools and frameworks. Like for example, I use like Cloudflare's, DNS 1.1.1.1, and you can apply that in multiple places. Like I use this on my phone with VPN. If you really don't want, you can use like Tor browser. Still some limitations apply, but like usually this goes against convenience, so you have to figure out the right balance. But the best way is to make sure that you're not leaving a very obvious, like, breadcrumbs, and hoping that people do not utilize it in ways that you do not agree to. Is self-supervised learning already implemented in the industry or still in research phase? It is implemented in the industry in more than one application. We just talked about one that's super useful, right? The NLP, BERT, and all the other like models that require very, almost like zero supervision, like in terms of like the data itself is self-supervising, right? So when you're talking about like BERT or any of these models that came and use the same kind of way of thinking, like masking certain words and like asking the machine to predict what the word is, that's self-supervising, and you don't need a human to go and say, well, I think this word is X, but it's much easier to like learn from a ton of data with like some masking like we did in BERT, versus like having a human going and saying, okay, this is how the language model works, and you have to come up with rules and some other things. That's like, for example, like computer vision, a lot of the time these are hand labeled examples, or in speech it's hand labeled examples. But if you can do something in speech, like it's supervised, like you get some set of data that you can use, and then from that you learn another data set and another data set, and you can keep refining the data as you go. That's another technique. There's so many different techniques, but short answer is yes, it's being used very successfully, if I may say that. As a consumer, how should I behave to protect myself, given corporations are generating a lot of data off of my purchases and behaviors? It looks like companies will gain more capabilities to process my data fast. You have a lot of choices. That's just a start. There's a really good TED talk about that, which is, I can't remember the title, but it talks about like if there's a Facebook or another company that gives you an option of paying instead of collecting your data and like targeting you with ads, would you choose that? So there's a choice of no use. If you're really keen on the privacy aspect and there's a problem with this kind of data use that you don't like, there's a choice of like switching. So between Google, you can go like if you don't really like being tracked at all, you can do like another alternative like DuckDuckGo. I personally use all of the products I just mentioned. Like I find Facebook very useful, I find Google very useful, and I'm okay with the trade-off. If you're not okay with the trade-off, I think you have a lot of options. I don't think there's a specific silver bullet solution, because I don't think that the behaviors are very clear today, that some of these things just happen because of the way data is collected. But if you don't like the data be collected, you can just stop the data flow. There are a lot of settings you can turn off on these products. They're very privacy aware. So you can turn off a lot of these things that allow you to like kind of quote unquote fly under the radar. Of course, it might affect some of the feature set that you're not going to get. For example, I used to work on LinkedIn for the newsfeed. And if you say, I don't want my data to be used for personalization, well, guess what? You're not going to get a personalized product. You're not going to get a personalized newsfeed. But would you be okay with that? Some people are, some people are not. The question is really about how do you protect yourself from malicious use of the data? And I don't think, for the most part, it's about being malicious. I think it's about the unforeseen, consequences of having so much data and second order, effects that you might not see right now, but in the future, that we, having all these IoT devices and having all of these like different connections could be made. What can be really used? It's unclear. So just be aware of what's going on. I think awareness is the first step. Understand what's being collected, and then think of like, what are you okay with and what you're not okay with. Okay, question about unsupervised learning and self-supervised learning. That's a good question. So unsupervised learning, you can think of it as like clustering algorithms, right? Like really, there are no labels, if you may, like just figure out, like, okay, I need to see different clusters or different groups for this data set. It could be like, marketing segments that are not necessarily clearly labeled, or you don't need labels for. You can just come up with a segment that's in a way like hard to describe. You can just inspect some samples and you say, okay, now I figured out this should be like this segment from the behavior that they're behaving together. Self-supervised is kind of like semi-supervised, just a different way of describing it, where you have some notion of labeling. Maybe it's smaller data set that's been labeled before, or you are literally working with the data that is self-describing or self-labeled, right? So we talked about that in NLP, having corpora for like learning a language model, right? The language model itself is learned by looking at the corpora, which is the data, and also at the same time the labels. All right, so question for Michael. I'm career switching from marketing to data science. I'm still learning Python, R, and SQL. What do you recommend I learn to prepare for the next wave 10 years? I think at the end of the slides, you will see some answers. If not, we'll come back to this question. So maybe actually jump here and we'll come back to questions later on. All right, so speaking of NLP and vision, there's been a lot of advances lately. Honestly, too fast to catch up with. I put these slides maybe a month ago or so, and it's been insane how much came out in that few weeks period. So this one here, the graph you see, is Mina from Google. It's a chatbot that introduced 2 new metrics for evaluating chatbots. So specificity and sensibility. And basically, you can ask questions to it and answer its questions as well. And the idea is like you can see how specific the answers are, or the dialogue. So if I tell you like something like, "Oh, what's your favorite movie?" and the chatbot, says, "I don't know," or "Yes," or something. Actually, "I don't know" is the one that would be penalized for specificity first. It's not a specific answer. It's still a valid answer, but not specific. And then it's not a sensible answer to say like yes. Like that's not actually, it's not specific and not sensible. But you can imagine how the current chatbots are performing. So humans are at 86%, which is really interesting. And then Mina is at 79%, and then multiple others that kind of they show like how much progress they made, like comparing them to Mina. So this one has been a huge model. I think it was 1.7 billion parameters. But honestly, since then, there's so much that came out that made it even look not that big. So you got like T5 came out with 11 billion parameters from Google. And then you have Turing NLG that came out from Microsoft. I want to say it was like 17 point something billion. I lost track of billions. Billions are now the new, millions. So for us, like talking about parameters and number of parameters and the size of the model, this is gonna really improve overall. Like the NLP models are getting deeper, getting bigger, and they're catching up with vision. And the reason why I'm using vision here as an example, like to follow, notice like lately, vision has been almost like so close to like human performance better in almost every task. You got a lot of advances in object detection and classification. You got ImageNet and huge data sets for like a lot of tasks and a lot of benchmarks. So there's been a lot of care and important progress in vision, and NLP is catching up and will catch up even more. You're going to see more and more advances there. So the holy grail is going to be summarization. I don't know how it's going to be in the next 10 years, but I think a lot of other tasks will follow suit with more of these cross-pollination ideas from vision into speech recognition or NLP and so on. So quick mention here that's important is abstraction in NLP. If you saw this paper from, I think it's Bristol Young and team, it's learning from definitions and understanding how you can do abstraction from definitions. So you can say okay, this is a chair. The chair has 4 legs and the base, and I can put multiple chairs in a room, and have a kind of row of chairs, and they have multiple rows, and they have a stage, and the stage is made of a platform and curtains and stuff like that. So you can describe in almost like a grammar language what these things are, and you can query the world, or you can do stuff about design, for example, by just talking. So you can give it a task to design a room by just describing everything in definitions, and then it can create that room for you, and it can manipulate the world using language, which is really exciting. All right, so data is going to be the new oil. There's no question about it. The question is what is that data that we've been working with then? I think of the data before machine learning as the ones we have been storing in databases and doing CRUD operations and reports and analytics and slicing and dicing, all the OLAP and cubes and all these things we've been working with. It's exciting, but it's not the same kind of data I'm talking about here. I'm talking about the new breed of data that's really the base or cornerstone for machine learning, right? And I think of machine learning now is going to be the new SQL or business intelligence or even Excel. It's going to be a kind of a skill that's required to get a job, right? If you think about it today, if you're a knowledge worker and you don't know how to use one of these, it's really putting you at a disadvantage. Same thing will be the new world we live in. Machine learning and AI specific, generally speaking, they have a lot of differences, right, in the way we think, decision making, for example. When you look at an Excel sheet and you try to make a decision based on the data, or you're being data driven, there's to a huge extent some determinism. You can see a plot, or you can see some table, and you can figure out, oh, okay, this is my median for this month. This is my mean and standard deviation for this distribution. You can see a lot of things that will give you some certainty, confidence interval. But then you have the AI, making very complex decisions, and have a lot of data coming in that you haven't seen before, or you may be required now to actually take that data and make recommendations that are not just here's the number from this time series, or extrapolate this time series. It's going to be a way more complex decision making with maybe as we saw millions of factors, not just a few factors, a few columns. It's going to be a much more complex world, and you have to understand what machine learning is all about. So same way we have been treating code as a necessity for a lot of the jobs in software and beyond, I think of data sets as the new code, right? There's so many different things that we build for code and software. So we build hardware, right? This is how you run your programs today. And the same thing is now really, I think, already established that we have hardware that's specific, ASICs and whatnot, just for the AI workloads, whether it's training or inference. You got these chips that are out there specifically for AI, and they've been super successful. There might be more coming in. I'm not going to talk about quantum computers in this domain, but just know that one of the main applications for it is going to be solving certain AI and machine learning problems. I also predict there's going to be more love and attention paid for math and probabilistic programming languages. So instead of thinking of the variable X as a memory location and some data associated with it, I think a lot of people are going to think of like a random variable or a distribution instead in the future. Just like we have, GitHub, which, yes, there's been a lot of version control systems before that, for Git, and there's a lot of innovation there. I worked on a couple of them. Yes, there's been a lot of places where you can store your code, but it's face it, speed it. Let's take GitHub made a huge improvement in especially in the open source community. It's a central place where you can go browse code and figure out collaboration opportunities and really get things done at a larger scale beyond your small team or organization or company. So if you think about that, can we have a data hub that does the same thing for data and data sets, where you can have discoverability, you can have the ability to collaborate, transform, and improve on each other's data sets. That's really what I meant here by data hub. Same thing with the data store, but for paid data sets. And yes, there are a lot of places today where you can go and buy off-the-shelf data sets, like Appen has one. Multiple companies have been setting up data. Actually, the name data store, I think if you go to datastore.com, it's going to redirect you to Salesforce, which, just as a trivia, also used to own the appstore.com, and then they gifted it to Apple when Steve Jobs was on the board, I think. So the idea is the data store, similar to how we had an app store for a while now. We will see a lot of the data marketplaces really more active and more enriched. So instead of seeing 1,000 or 2,000 data sets, it will be in the millions or maybe the 100 millions at the same scale you see app store apps today. And all of the above will actually require more of complete solutions in terms of licensing, ratings, reviews, etc. All of these things that kind of are a support system to make sure that you have the ability to review an app. You also have the ability to review and rate a data set and figure out how to try before you buy and all that interesting stuff that you'll see with an ecosystem that is supportive of such activities. Now, on the application lifecycle development, you'll also require more and more investments in debugging, extendability, QA, testing, really deployment, ML ops, generally speaking. The need for best practices is going to be extremely, extremely important. The idea of explainability and having something that really tests different, aspects of your model. Hey, is your model biased or not? But I mean bias in the technical term for machine learning, but also from the kind of social responsibility, right? Gender bias and other terms of other places where you have to test for, is this going to have a inverse or the bad impact on a certain group, right? Or what kind of social impact does it have? Even if it's environmental impact, is my model doing the right thing when I have to train it on I don't know, thousands of machines and burning that much energy just to get the model? So I think it's a great thing at NeurIPS for 2020, assuming everything goes well. They required for the call for papers a new section on the social impact of your model. What does it mean when you apply your model in real life, and what implications does it have? So with that said, I just want to mention something that's more of an observation. We have somehow somewhat mastered the code, traditional code, life cycle, and how to build some software packages and deploy them and ship them and maintain them and so on. But we're not that good about it yet when it comes to AI. So somewhat clueless, I would say, actually, especially when you think of the cutting edge kind of advancements and how theory has not caught up yet to the empirical or applications. The idea is that we have a lot of work to do here. So I think of it as it just takes time. Think of all that time it took us, right? We've been debating about the best practices to do things, including all the small nitty-gritty things like nitpicking, is it 4 spaces or one tab or two spaces, in JSON, or 4. All that stuff has been really the accumulation of millions of hours, a lot of books, talks, dissertations, PhDs, very smart people thinking about these processes and coming up with standards of what works when, and a lot of principles came out from that. I don't think we're there yet with AI. We just need a lot of time spent to really figure out like all the meticulous details, and eventually we get there. The nice thing about it is that we don't have to start from scratch. There are a lot of things that could be an analogy to use and improve upon, just figuring out what works in AI and what doesn't. So takeaways, there's a new breed of data, a lot of certain skills that are coming about that you have to think about. So what do you need for job search in 2025, right? What do you need for a job search in 2030? And then if you were to start a new company or invest in a company, what is it that you have to ask in terms of like how the future of the AI industry gonna be like, and what is equipping the company to actually have a fighting chance to win? And you need to prepare your current business, your current team for what is to come, just knowing, and more importantly, making up your own predictions and figuring out like the landscape and coming up with your own ideas and bets is the goal of today. So if there's one thing I'd like you to do is to take a few maybe minutes today to just think about like, how are things around us, how far we've come, where are we when it comes to AI and all the different fields that we've been hearing about and learning about, and then where would this lead us? Where would the future take us, in this decade? And hopefully by the time, it's 2029 in December, on the 31st of December, and you're sitting down in a nice restaurant having dinner and like waiting for the New Year's, you would think like we've come even further than we've ever dreamt of. So with that, thank you. I just want to make sure that we're part of that future, and you have a lot of opportunities to do that, to make it happen. Invest in a skill that is matching what we just talked about, whether it's open source project or starting a company or getting your team prepared. I think the best way to do it is to build it together. All right, so I'm done with the talk portion, and I'd like to go back to the couple of questions I skipped. But before that, I heard some microphones. Just give me 1 minute to go through the couple of questions, and then we can open up the discussion if you don't mind. So Michael's asking about career switching from marketing. I would start with saying, yes, you're on the right track. You gotta understand the different machine learning, programming, like, constructs and languages and things that really you require to work with data. For that specific track, shameless plug, we have actually 3 chapters that talk about like just the languages you mentioned there, Python, R, and SQL in the book Computing with Data. I would recommend also understanding system design, just how you can connect the dots and build up some system from A to Z that works with big data. And from that, you can start thinking about data analytics, and hopefully you'll find a track that matches what you want to do as well. So yes, of course, there's a lot of benefit in doing what others have been seeing as successful, but if you match that with something that you find that, you find yourself passionate about, I think that will be even a better approach. Question about GDPR again. Don't you think government must come up with the new organizations such as FDA to address and regulate AI and ML? That's a very controversial thing. I think it will happen eventually. I don't personally think it has to come from, a specific government, including ours. It could actually come from, civil groups. I'm more interested in the impact they have than the source of like the regulation or rule or like best practices. Like at the end of the day, customers vote with their feet, right? So the challenge is when customers are not aware of what could be happening, and maybe there's like, malice included or involved, how can we regulate that? So certain domains, they already have regulations. So yes, it's already started. like HIPAA compliance is very important for regulations when it comes to like, medical data. GDPR is already there, CCPA is already there. So it's already happening, whether there's a federal agency or not. It's just an example of what could happen. But the more important thing is like, yes, we need some entity that is at the very least make customers aware of the level of like, data use that is okay and, healthy, and the level of data use that could be really not the best for the customers or the society in general. All right, so we can now move to the discussion section. Any questions on the call?
I think we got all the questions. I would like to say thank you for your time and this great presentation.
Yeah.
And thank you everyone for joining us today. We will talk about anomaly detection using AI techniques tomorrow, and you can see the details on our website and meetup page as well. And hope to meet you again for next events. Thank you.
Well, thank you so much. It's been a pleasure.